Welcome back to day 20 of our Python journey here at Edulexis. Today, we're moving beyond ordered lists and mapping keys. We're diving into sets, the most efficient way to handle unique data and perform mathematical wizardry. A set is an unordered collection of items where every element is unique. Think of it like a bag of marbles. The order doesn't matter, and you can't have two identical marbles in the same bag. The biggest superpower of a set is its ability to automatically filter out duplicates. If you try to add the number 5 10 times, Python will shrug and only store it once. Let's look at how that looks in the terminal. To create an empty set, you must use the set constructor. Why? Because empty curly braces are reserved for dictionaries. It's a common pitfall, so keep that in mind as we start coding. Notice that when we print our set, the order might change. Sets are unordered, meaning they don't support indexing. You can't ask for item 0 because, in a set, there is no 0, there is only presence or absence. Because sets use a technique called hashing, checking if an item exists in a set is incredibly fast, much faster than searching through a list. It's the go-to tool for membership testing. To expand our set, we use .add for a single item or .update if we want to dump an entire list of new items into the set. Remember, duplicates will still be ignored automatically. Removing items can be done via .remove or .discard. The difference, .remove, will crash your program if the item isn't there, while .discard will just move on quietly. Choose wisely. So far, we've mastered the basics: creation, uniqueness, and modification. But the real reason we use sets is for mathematical operations. Let's get into the heavy lifting. In mathematics, sets are used to find relationships between groups. In Python, we can do the same with union, intersection, and difference. This is where your data analysis skills truly begin. Imagine you have two newsletters and you want to send a single email to everyone without anyone getting a double. A union is your best friend here. It merges and cleans your data in one line. Next is intersection, using the ampersand and. This finds only the items that appear in both sets. It's the common ground. If it's not in both, it's out. Let's code a quick script to find common followers between two users. By intersecting their follower sets, Python instantly returns the overlap. Fast, clean, and efficient. Difference, using the minus sign, returns items in the first set that are not in the second. It's like subtracting one group from another to see what's unique to the original. Keep in mind, order matters here. A minus B is very different from B minus A. One shows you what group A has exclusively, the other shows group B's unique members. Symmetric difference, using the caret, is the opposite of intersection. It gives you everything except the items they have in common. It's the either-or of the set world. Time for a challenge. Pause the video. I want you to take this list of names, many of which are duplicates, and turn it into a set of unique, uppercase names. Try it now. Back. The cleanest way was a set comprehension or a simple set cast. Notice how Python handled the case sensitivity. Alice and Alice are different unless we normalize them first. Quick tip: if you need a set that cannot be changed, immutable, use frozen set. Since they can't change, they can actually be used as keys in a dictionary. If you want to modify the original set directly rather than creating a new one, use update methods like intersection_update. This saves memory when working with massive datasets. For my CS students, sets use hash tables. This means searching is generally O(1) time complexity. Compared to a list's O(n), sets are a performance powerhouse for large data. Let's build a real-world tool. We have a set of blacklisted IPs and a list of incoming traffic. By using a set intersection, we can flag malicious users in milliseconds. Watch as I type this out. We define our blacklist, we convert our logs to a set, and boom, the intersection shows us exactly who shouldn't be here. Minimal code, maximum impact. Warning, you can't put a list inside a set. Items in a set must be unhashable, immutable. If you try to nest a list, Python will throw a type error. Use a tuple instead. Let's recap. Sets give us uniqueness. Union joins. Intersection finds commonality, a difference subtracts. And symmetric difference finds the unique outliers. Your homework: create 2 sets of your favorite movies. Find which ones you share with a friend, and which ones only you like. Post your code in the comments below. If you found this helpful, subscribe to Edulexis. We're building a community of logic-driven developers. Check out the resources in the description for today's cheat sheet. Tomorrow, we tackle dictionaries in depth. Keep practicing your sets, they are the key to writing efficient Python. I'm your host from Edulexis, and I'll see you in the next lesson.
Thank you for watching. Like if you learned something, share with your circle, and subscribe for more.